Yeah, by Colorado. You're gonna be able to come? Well, I do think PCC, but I call it PC. Yeah.
Okay, next one is 33. You get an extra test bonus. Again, trying to get you thinking of the test because it is approaching. On the test, I guarantee you, you will see at least 2 problems that deal with the idea of a horizontal asymptote. That does not mean that you will see 2 problems that necessarily look like number 33. But you will see 2 problems that deal with the concept of a horizontal asymptote. Okay? Now, warning. In past years, the questions that dealt with the idea of a horizontal asymptote were missed usually more than any other question on the test. So as we talk about a horizontal asymptote, you just have to keep digging and digging and digging until you feel like you've talked about every little part of it that could possibly come up on a question. So ask as much as you want. All they tell you is there's a function, and they tell you that this function has a horizontal asymptote at y equal 2.
It also tells you that there's a vertical asymptote at -3.
Oh, thank you. My bad. I was so focused on the horizontal, I completely forgot the vertical. So as Jeff said, they also mentioned a vertical asymptote for an x value of -3. Any questions so far? Awesome. Okay, seeing those 2 clues, what you need to figure out now is how to proceed. So my advice is this. When you hear the word horizontal asymptote, if you'll kind of think of a graph, it always helps. So someone tell me, when you hear the word horizontal asymptote at y equal 2, what kind of thing might you sketch quickly on a graph? Just somebody raise your hand and say, what kind of thing might you sketch quickly? Let's go, Braden.
Would you draw a line at y equals 2?
So Braden says, come up here to y equal 2. Some sort of horizontal line. Every comment is 2 tickets. Well done, Braden. The question. The most important part, though, is this. Don't forget. The horizontal asymptote only deals with what is happening as x is very large.
Yeah.
So when x is very large, we know that the function will have y values that get closer and closer to 2. But that tells us nothing about what's happening over here. So over here, anything can happen. Everybody with me? Awesome. Okay, another thing you should have memory. Oh, please, Chad.
Could it approach 2 from the top as well?
Oh, yes, thank you. The function could have easily have done this.
And will that like affect it or not really?
Not for what we're studying. It doesn't
Okay.
really come into play. It's just x is approaching 2 either way.
Okay.
I believe it can even do this, Chad. 3 points for Chad. Very good question. I'd have to look this up in a math book to see if it fits the strict definition.
Yeah.
But it makes total sense to me that the function could do this and continue to oscillate, but just get closer and closer to 2.
never.
So it would actually always be going up and down, just getting closer and closer to 2. To me, that would be a horizontal asymptote. Any question? Awesome. Memorize fact. Somebody will remember it. When you see this, you should visualize this, but then you should also remember to write down something else that's related. There we go. All know, actually. All know. What are we supposed to have memorized to write down? I'll pay everyone who raises their hand. What are we supposed to know to write down? Let's go. Landon?
X goes to infinity. The limit is x goes to infinity.
Nicely done. Landon. And 2 points for all others who raised their hand. Okay, the limit is x goes to infinity of what? What belongs here, Landon?
I would just say ax plus b over x plus c.
Nicely done. That's exactly what it means. You're trying to figure out, as x goes to infinity, what will this do? That's exactly what we're doing. And what does that all have to equal? Right? 2. Any questions? Perfect. Okay, on the AP test, it's very common to encounter something like this, where they are giving you some sort of information like this, like an equation, and they want you to figure out the value of a constant or constants. Okay, when this happens, just remember to do the following. Ignore the fact that you already know the result and focus on solving this as though you didn't know the result. Questions? So we're going to ignore the 2, and we're just going to solve this. Go.
So then you would just need to focus on the exit for the lowest common term.
Nicely done. So Oakley does a additive comparison, comes up with a new limit problem. The B becomes insignificant, as does the C. He ends up with this. Anyone have a question to that? Oh, please.
Since the X and the C could also, could you do either one? So like on the additive comparison, right? You're just kind of making one insignificant. Could you make either the X or the C insignificant, or would it just be the C?
Excellent question. Let's see if this will help make sense of it. Okay, C can be any value.
Yeah.
So it could be very, very large. But by definition, because C is considered to be a constant, it's not going to be a changing value.
Okay.
It's just some unknown value. So let's say that C is equal to 1 trillion. So it's very large. Okay, X starting out, when you add X plus C, the C will dominate.
Yeah.
But X is allowed to grow to infinity. So it keeps going, keeps going. This one doesn't change.
Yeah.
Eventually, X will be still so much larger than C, it will still be the dominant term. So no, X is definitely the dominant term. Did that make any sense?
Yes.
Very good. Anyone else? Cool. If we're trying to solve this limit problem, ignore this again. So ignore this. Tell me what is the answer to that limit problem for him. Go, Deborah. Well, the answer to this one is 2. We're going to know that in a second. Yeah, that's what I wanted to point out, is that we kind of pretend we don't know this one, and we focus on this. The answer is A. That's what tells us that A is 2. Questions from anyone, please? Everyone totally comfortable with the ideas, not the problem, but the ideas. Good. We still need to take care of the vertical asymptote.
Question.
Oh, please, please.
So, how, sorry, just remind me how not the limit equals, like those two X,
So this one here, Ellie.
yeah, because, yeah.
Very good. Memorized fact. The word horizontal asymptote means exactly this.
Okay.
So that one you just have to memorize it. Horizontal asymptote, and this means the same thing.
So you just ignore the vertical asymptote?
Temporarily. Kind of picked a clue, worked on it. Now we're going to pick the other clue and work on that. Now you have to have memorized what vertical asymptote means. So somebody raise your hand and tell me what is vertical asymptote. Chance.
When the denominator in a fraction is 0.
Nicely done. So we have the denominator, which in this case, our denominator is X plus C. We need that denominator to be equal to 0. Sorry, wrong one. We need the denominator to equal 0. So X plus C has to equal 0 for X equal -3, because -3 is the location of the asymptote. Therefore, -3 plus C must equal 0. That allows us to conclude that the C value is 0. That would be really awkward to say 0.
I was like, wait.
Raise your hand if you noticed that mistake as I made it. Raise your hand if you noticed the mistake. 2 points for those of you who noticed. Thank you. Any questions? That completes the problem.
So the C deals with the vertical asymptote.
It turned out that the C value was, we found out using this clue, the vertical asymptote, and the A value was found using the horizontal clue.
So if the C happened to be on the top, then it would be separate.
It would probably switch, yeah. No, it's very good. Hey, you can't ever tie symbols directly to some meaning. The A in this problem is just some letter that's representing an unknown number. It has no special meaning.
How did you get it?
Oh, again, memorize fact. If the function has a vertical asymptote at x equal 3, that means that for an x value of 3, the denominator of the function has to equal 0. So you build from there. Next one. Okay, everyone needs to memorize something. There's a really distinct pattern. You'll need it the whole year long. It relates to the natural log function. So we're talking about problem 35, which involved the natural log. 35 cannot be solved unless you have this idea memorized. Now, there's a pattern to this table that I'm going to show you. There's a pattern. So there's a pattern to this table. Let's start here. If the x value is equal to simply e, that means we're trying to find the natural log of that value. We're dealing with the natural log function. So we plug in the e value into the natural log function, and we know that that's equal to 1. If you have forgotten that, it's okay, just need to memorize it now for the rest of the year. So if the value of x is e, the natural log of e is equal to 1. Questions so far? Okay, there's a really easy pattern. To pick up on the pattern, what you need to memorize is very simple. So e squared. If I plug in e squared, the natural log of e squared turns out to be 2. If I plug in e cubed, the natural log of e cubed turns out to be 3. I'm hoping you're starting to see the very simple pattern. Now we've got to work backwards. So let's see if somebody has noticed the pattern. Someone raise your hand and tell me what I should type, or what I should write here. See if you can guess the pattern as it goes back the other direction. Let's go, Tara.
E to the 0?
Nicely done. E to the 0. We'll find out that e to the 0 is 1. You've heard that before. So the natural log of e to the 0. And what will go here, Tara?
0.
0. So Tara sees the pattern nicely. Questions? Please.
What is E equal to by itself? Is that 2 point something?
About 2.7.
Okay.
That's an approximation because it's a decimal that goes on forever. But that's good enough for our class.
Okay.
Helps you get a kind of a feel. So the natural log of 2.7 is exactly 1.
Okay.
Any other questions? If we keep going, the next one, somebody can predict the next one if you just follow the pattern. Glenn?
Would it go to the negative, so e to the negative 1?
Perfect. So this is the natural log of e to the negative 1. And what belongs here then?
Negative 1.
Negative 1. Somebody else tell me, what's a different way to write e to the negative 1? Let's go over here to Yossi. Nicely done, 1 over e. Is everyone comfortable with the pattern? The pattern needs to be memorized. Because what happens is, on the non-calculator portion of the AP test, it's actually fairly common to have a problem dealing with natural log, and you have to have these values memorized. No others are required, just these. Cool. The limit problem you hit in 35 looks like this. It said the limit, as x approaches 1, of x divided by natural log of x. Okay, because x is not approaching infinity, we can't use an additive comparison. We can't try and figure out which function is larger. None of that works. We're stuck with just plugging in values. So a table is an easy way to represent that. So when the x-coordinate is close to 1, we're going to get this situation. Questions? Right, so you need to have memorized that the natural log of 1 exactly is 0, which means this will become, let's see, it'll be close to 1 on the top. So the natural log of 1 minus is going to be just a little bit less than 0, which means that's pretty much this kind of a number. Okay, now you have to remember what division means. Division means how many of these will fit into this infinite number. And then the last thing you think of, Soren, is positive divided by negative is negative. So far we know the limit from the left is negative infinity. Questions? Write that down, I suppose. This is telling us the limit as x approaches 1 on the negative side, the value of that limit is negative infinity. Easy question, I just want to give somebody some points. To finish the limit problem, what are we still required to do? Looking for a hand. There we go, Jackson.
To the positive side, too.
Got to find it from the positive side. So plug in more than 1, I get 1 plus, natural log of 1 plus. That's going to be 1 over just a little bit more than 0. So that's going to be this 1 all over something like so. So what's that, Jackson? Infinity. Questions? Therefore, the overall limit, the answer to the problem here, what is it? Non-existent. Follow-up questions. Please, Brady.
Why is it non-existent?
So the rule of limits is, if you find the limit from the left, the answer is a value, and then you find the limit from the right, so you basically discover that if we get close to an x-coordinate of 1, from the left, we're getting close to a y-coordinate of negative infinity. We're getting close to an x-coordinate of 1 from the right, we're getting close to a y-coordinate of positive infinity.
Oh, okay.
Therefore, in general, we do not know a single value that we could say we get close to. So that's a good question. What else? Nice focus. Good work. Next one. Okay, 36. 36 wants us to find the limit, again, as x approaches 2. All I need to do is find the value from the left and the right. So I plug in a little less. According to this definition, that means I use the upper formula, so this becomes the natural log of a little less than 2. Okay, notice, this is not one of the natural log values that you need to memorize, so don't do anything with it, just stop. You're not expected to know what this is as a decimal, so just stop. Now we check a little bit more than 2, and we must use the bottom formula. That comes out to be pretty darn close to 4 ln of 2. So as x gets close to 2, are we getting close to the exact same y-coordinate, or are we getting close to 2 different y-coordinates? Two different ones. Therefore, the limit is non-existent.